Let me give you guys an example of integration by substitution. So let's say you've got a circle of radius A. So a circle of radius A, and the vertical height here is B. So from here to here is B. And the equation of a circle of radius A is given by this. So the area of this thing here, to find out the area of this thing here, we could do this. We could sum up all these slices here. So we could. So if you look at the thickness associated with this one particular slice, the thickness is dx. So one way of finding out the area would be for us to sum up all the heights here. So the height here would be y, and then because we're moving in the x direction, then we need to sum up. So this here would be dx, and we need to do it from 0 to the radius, which is a, from 0 to a. So this is one way of finding out the area. But the thing is, you need to, as you're moving in the x direction, you need to know the height each step of the way. So you need to know the y value each step of the way. So as you're summing up in this direction, you're moving along you're moving along in the x direction. But as you're moving along, you need to know the height. So the height here is b, 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 and then by the time it gets to here, it will change. So you have some sort of difficulty around here. Here it would be easy. So another way of summing this up would be, another way would be for us to break it up into two sections. So we could take the integral from so y dx here from 0 to, let's say this here is c, from c, and then plus it with c to a here, and then you could do some other. Well, that's one way of doing it. Another way of doing it would be to sum it up in this direction here. Another way of doing it would be for us to sum it up in this direction here. So we are summing up everything here. If you look at the thickness associated with this one particular slice, it will be dy. So you're moving in the y direction now. So the area could be from 0 to b. So from 0 to b, and then don't forget you're moving in the y direction because you're summing up. So you're moving in the y direction. So this, but well, as you're moving in the y direction, hang on, let me just clear this up. As you're moving in the y direction, you need to know the x value each step of the way. Well, the x value here would be x. So this here would be another way of working out the area. Would be you taking the integral of x dy. Okay, so that's one way of doing it. But if you look at this equation here, so one way of doing it would be for us to sum up all the slices in the horizontal direction. But then so one way of doing it would be this, from 0 to b. But then if you look at the equation now, we need to rearrange it so that we have a term for x. So as we're moving in the y direction, we need to know the horizontal distance from here to here. So that would be so looking at this, it would be you adding x squared to both sides equals a squared, and now take away y squared. So this here would be this a squared minus y squared, and then you would square root both sides. Now you have a term for x, so you can put it into here. Okay, so now so the area, we can work out the area by doing this, and then by looking at this, we can put it into here. So now we need to, well, now if we want to know the area here, we just need to evaluate this. We just need to find the integral of this. But the thing is, at the moment we don't have enough knowledge to integrate this. We cannot at this stage. We don't know how to integrate this, because if I were to ask you to integrate this, your normal routine would be, well, let's rewrite this as a squared minus y squared to the power of a half. At the moment, currently, this thing here is this thing here. But for us to integrate it, we need to to make our initial guess. So we need to look at this, and we need to have one higher than that. So that would be 3 over 2. 3 over 2. So currently, what I'm saying is that at the moment we don't know how to integrate this. Our knowledge is not good enough, because if we try to integrate this, our normal routine would be to rewrite this as a squared minus y squared to the power of a half. So if we want to try and integrate it, we would make this to be our initial guess. But this being our initial guess, when we differentiate it, it would give us this. It would give us, well, this thing goes down, so that would be 3 over 2 a squared minus y squared, and then this gets minus by 1, so that would be this. But then we need to times with the derivative of the bubble itself, which would be negative 2y. You see, when you try to make this to be your initial guess, it will give you this. But when you look at this, there is no y. You see, this y here gives us a lot of complication. We don't have enough knowledge to integrate this. If we try and do it with our normal method, we will have this y lingering around. If you look at this, if you look at this, there is no y lingering around. So hang on. So if you look at this here, it's just simply to the power of a half. You see, we can get rid of this easily. We can negate the negative 2 easily. We can negate this easily. But here you've got a y lingering around. But then if you look at the original form, we haven't got a y lingering around. But here you've got this y here complicates everything. So to integrate this, we would need to well, one way of integrating this would be to introduce polar coordinates. Okay, so if you look at the normal Cartesian coordinates, let's say this point here, you could say this is let's say this is so any point you can state the location of this particular point. So the location here is 7, 3. If you look at this, let's say this here is you could locate this point here by saying, oh, let's just say this is 2 and this is 9. So you have a way of locating any point on a plane. But then by looking at polar coordinates, you see we need to introduce polar coordinates in order to evaluate this. But with polar coordinates, you can still locate any point on a plane by just stating, well, with polar coordinates you have everything radiating from the origin. Okay, so if you have let's say this point here, then to state this location, you would specify the angle theta, and then you would specify the radius, and then there you can locate any point on a plane. So if you have, let's say, if you have your plane here, let's say you've got this point here, then you can locate this point by stating the angle here, and then by stating the radius here, then you can locate any point on a plane surface. Okay, so well, we will continue in the next video. We need to introduce polar coordinates to this in order to evaluate this. Okay, I will continue in the next video.